Hi, can someone confirm if I'm audible?
So,
Uh, okay. So, I hope you can see me. Okay. So, hello everyone. My name is Agnik. I am I am currently a PhD student in IISc Bangalore, and I am a TA for this course, machine learning. So, just admit a few more people. There are still people joining, so I'll wait for a couple more minutes and then we can start our session. Okay, that's I think that's enough people. I'll start. I'll share my screen. So I hope my screen is visible to all of you. Um, okay, let's.
Yes, sir.
Yeah. Hi. Um, so I hope my screen is visible to everyone. Okay, so yeah, welcome everyone to this first session by me. I'm Sagnik. I am a PhD student at IISc Bangalore, and I am a TA for this course, machine learning. And I'll be taking sessions every Monday from 6 to 8. So there are two other TAs who are working with me. They'll take sessions on different days, so you will be notified of those by the NPTEL team. In this first session, so I'll just quickly go over the objectives. So since I'll be covering some topics from, I'm sorry, there are still people joining the meet. So okay, cool. So I'll be covering some topics from week 1 and 2 because none of the concepts that were covered in both these weeks were mathematical of any sort. So there are no real sample problems which I could come up with or which were available to me. So I'll just quickly recap some of the concepts which the professor taught in the first 2 weeks, and after that if you have any doubts then hopefully you can clear those. And yeah, so one point to note is that one point to note is that please don't ask me any direct questions from the assignments. So I won't be able to answer those. If you have any conceptual doubts, then yeah, sure, we can discuss that. So yeah, let's start. So I'll Yeah. Okay. So first of all, we since we are learning machine learning, so the ultimate goal of machine learning is to create a. Sorry about this. There are there are a lot of people who are joining this call. Um, I don't know. So from next time, I'll figure out a way to allow people to join without me approving every request. So we'll do that next time. Anyway, so yeah, as I was saying, uh, and so the ultimate goal of machine learning is to is to create uh, is to finally create an intelligent autonomous system, right? So what do I mean by that? So an intelligent autonomous system should be able to function on its own, and and by functioning on its own, I mean it needs to have three main characteristics. Okay, I think I will stop admitting any more people because this is. Let me see if I can. Okay, anyway. Yeah. So, what do I mean by an intelligent autonomous system functioning on its own? I mean that it should have three main characteristics. So, first of all, before discussing those, first of all, every autonomous system should incorporate a model of the world. Okay, so it needs a model where it knows how to function, and in that world, in that model, it should be able to do three things. First thing is to perceive. So by perceiving, I mean it should be able to sense. It should be able to sense its surroundings. It should be able to collect data about its surroundings, uh, and it should be able to aggregate and understand that data. Then with this data, it should be able to think. By thinking, I mean it should be able to analyze, reflect, and reason using the data and the data which it has collected using its sensors. And after thinking, it should be able to take some action. So there is no point of a model just thinking on its own without taking any action. So in order to take action, it has to plan. There has to be some rules of action, and finally it has to perform those actions. And you see that there is no point in a system taking the same action every time. So the final step is that a model, this autonomous system, should be able to learn from its actions and improve its perceiving and thinking capabilities. So this is how the flow, you can say, goes. So we start with the model of the world, we perceive, think, take some action, learn from our actions, and the process continues. Right. So the next concept which I'll discuss is some applications of machine learning. So machine learning has been extensively applied in industry and academia in several. So there has been several cutting edge products, cutting edge research which is happening in machine learning, and the most popular of them all, I think, is computer vision. So this is the hype right now. So these are So computer vision is designed for tasks which require the human visual system. So the most popular example of this is self-driving cars, which so self-driving cars use computer vision in abundance, and the technology has gotten so much better recently due to advances in computer vision technology. So, what does computer vision actually include? It includes object detection and tracking. So, the my machine learning system should be able to detect objects, detect multiple objects of multiple types, I should say, and track them through time. It is also it also includes scene reconstruction. So this is very useful in the case of forensics or even self-driving cars, because cars need to model the surroundings to drive. And finally, it is also used for image restoration. So taking old images and trying to restore missing pieces in those images, or yeah, and applications of that kind. The second most popular machine learning application is speech recognition. So by speech recognition, I mean it should be able to recognize speech, recognize language, and it should be able to translate that speech into text, or to other languages, or to other spoken languages. So, speech recognition involves both acoustic modeling and language modeling. By acoustic modeling, I mean how like language is spoken. So, right now I'm speaking in English. So, a machine learning model should be able to identify these different sounds and recognize them. So, this is acoustic modeling. And language modeling is also important, because the machine also needs to understand that this is a language called English, and these are the sounds which are produced in English. So acoustic and language modeling are both very important parts of speech recognition. So, speech recognition can take two different subcategories, I should say. So, the first is speaker independent systems. So, these are usually used for translation or speech to text. So, uh, if you open up your phone and talk to Google Assistant or Siri, then it translates your speech to text. So that is a speaker independent system which they use. There are also speaker dependent systems which are used to fine tune the recognition of a particular the recognition of speech of a particular person. So this is something which the assistant on your phone can also do. So it is used for identification and verification for security purposes. The third application of ML is data or text mining. So, data mining involves extraction of patterns in data from a large data set. And text mining is similar to data mining in the sense that we mine text instead of data like images or videos. So text mining has the additional benefit that it can identify concepts, topics, and keywords from large amounts of text. Just one second. There are some Yeah, so these kinds of systems are mostly used by businesses. So e-commerce systems use data mining to identify patterns in how you purchase products or how you view products. So if you go on Amazon and you view a product, then if you scroll down, then you can see that there's a section called people who viewed this also viewed, right? So this is something that Amazon can do because it has a very large data mining system. It is also used in recommender systems. So when you watch a movie or when you watch a series and you get new recommendations, so that is based on that is based on data mining, and it is extensively used in social media. It is also used to identify patterns in financial data sets. So banks and financial institutions use this a lot, and it is also used nowadays to augment knowledge-based systems through text mining. So if you so the uh, this the recent hype is chat gpt or even GPT-3, which was developed by OpenAI. So they used so the selling point of those algorithms is that they have been trained on a large corpus of text. Okay, so this has been possible only through data and text mining. So the way that OpenAI collects this sort of data. So whatever data they collect is available open source. They collect it from Wikipedia. So GPT-3 was actually trained on the entirety of Wikipedia, so which would not have been possible without data mining. And finally, the most ambitious application of machine learning is adaptive control. So this usually involves the use of reinforcement learning, which I'll discuss in a little bit. But adaptive control involves improved control methods to control a system in uncertain environments or changing parameters. So I'll discuss more about this when I go over reinforcement learning. So some examples of this is fully autonomous driving and robot control. So robot control is a very big part of what adaptive control is used for. So I don't know if you watched videos of Boston Dynamics using adaptive control in their robots to perform a variety of tasks. It is indeed very interesting. I think you should watch it on YouTube. So yeah, okay. So now we saw the applications of machine learning, but how do you actually go about building a machine learning model or building a machine learning algorithm? So the first step is data collection. So from multiple sources. This is usually in very large scale systems. Sorry. So yeah, in very large scale systems, this is usually achieved through data mining, as I said. Then we have to pre-process the data. So pre-processing involves, cleaning up the data and like uh, so it involves cleaning up the data, filling in missing values, or deleting some data which you think is which we think is not useful or incomplete or even wrong. Okay, then comes feature engineering. So I'll discuss this in detail later on. Then we decide the model or theory that needs to be used. Then we select an algorithm that we want to train based on the data and based on the task that we are doing. Then after selection of this algorithm, we need to tune the model. So tuning involves tuning the hyperparameters. By hyperparameters, I think we'll come across this when in the later weeks. So then for tuning the model, we need to look at its complexity, look at the bias that is generating, and finally we analyze our results, and there is some post processing of the acquired knowledge. So where does the actual machine learning flow come in? The machine learning flow comes in from the pre-processing to the analysis part. So here is where the machine learning, or where machine learning engineers work from pre-processing the data to analysis of the results of the model. Okay. The next concept that I want to discuss is the types of ML problems, types of machine learning problems. I will stick to supervised machine learning problems for now. I'll briefly talk about unsupervised learning models after. So, in for supervised learning models, there are two main categories, and the third is something called reinforcement learning. So the first category is regression. So in regression, we want to predict the desired target quantity when it is continuous in nature. So say I want to predict. So yeah, here I've given an example. So say I want to predict the price of a house based on certain characteristics. So the price of a house can be determined by its area, its location, number of rooms, number of bathrooms, whatever. So there are you can think of any number of parameters which can predict which can help us predict the price of a house. Uh, sorry, sorry. There's a lot of noise coming. So I request you guys to mute yourselves. Okay. So please keep yourselves muted unless you have a question. So sorry about that. Okay. So people, okay, good. I'll stop admitting people now. It's 20 minutes. So yeah. Okay. So as I was saying, so if I want to predict the price of a house, then you can think of any number of characteristics, and the thing is that the price of a house is not some category. So it is a continuous value, right? The price of a house can be anything, and it is a continuous value. So I need a regression problem, a regression model to predict the price of a house. The second kind of machine learning problem is classification. So this is used to predict a category from a discrete number of possible outputs. So say I have the example that I've given here is predicting the category of an animal, given a list of features about that animal. So say that animal has the number of legs it has, if it has a tail, if it there are any number of characteristics, any number of features which you can think of. Another example would be if you want to predict, say you have a large image data set of vehicles, and you want to predict whether a particular vehicle is a car or a bus or a truck or a train or anything. So classification. So this would require a classification model to do this task, to put these images into their categories. And the final a kind of learning problem, which is not which is not fully a supervised problem, is called reinforcement learning. So in reinforcement learning, what happens is we have an agent, and it is in an environment, uh, and the agent will take certain actions to maximize a reward. So we define the notion of a reward for the agent, and the only task of the agent is to take different actions and see if its reward increases or decreases. So if the reward increases, then the agent is more likely to take that action another time, and if the reward decreases, then that agent will stop, will reduce taking that action. So these actions are modified over time to produce new states and new actions in order to maximize this reward. And there is one very interesting feature of reinforcement learning, which is that it functions without having prior knowledge of the world. So I had mentioned before that an intelligent autonomous system should have a model of the world, but reinforcement learning problems can work with agents who have no prior knowledge or no prior model of the world. So the agent learns a model of the world based on this reward factor. So a classic example of reinforcement learning is an object which is at the center of a maze, and it has to try to find its way out. So the in order to find its way out, it has to move in a particular direction. If it hits a wall, then it will probably turn back. Its reward will reduce, and it will not probably go in the same direction. It will try different directions, and it will build a knowledge of the world based on this reward factor, right? So okay. So I've been talking about this machine learning models, but what actually is so how can we actually start training machine learning model, or how can we start working with machine learning models? So the first two things that we need to know are objects and features. So the object is the data or the observation. In machine learning terminology, it is often called a data point or an example or a training example, or you will hear multiple names. So, but most commonly, I think it is called by data or an example. And what is a feature? A feature is what characterizes an object. So an object is characterized by its features. So the features define the object. They are often called properties or attributes. And the goal of an ML algorithm is that if I give it an unknown object, it should be able to predict the features of that object, or if predict a feature or predict multiple features of that object. So that is the goal of an ML algorithm. There are different kinds of features which you use. So the first kind is an ordinal feature or a binary feature, so only 0 and 1. So say something like, so if I have a feature like, say, yeah, so if I have an image, if I have attributes of animals, say, so if the animal has a tail or not, so 0 or 1, right? It can be discrete numerical, so it can be one number out of a set of numbers. So say the number of legs which an animal has, so 2 or 4 or 3 or 6, whatever. So this is a discrete numerical value. It is not continuous. So an animal cannot have, you know. Discrete numerical values are usually integers. So an animal cannot have like 3.5 legs or something like that. Then there's continuous numerical values. So in the case of predicting prices of houses, so the prices are continuous numerical values. The price can be anything. Then there's symbolic values, which are usually text based values. So say the name of the animal. So say a cat or a dog. So these are symbolic values. And finally, the most complex kind of feature which we can have are structural. So these are graphs or lists or arrays which are related to a particular object. Okay. So now that I have my features and my objects, so how do I go about learning? So what does a typical learning task involve? So first of all, I have to define the appropriate features which I want to use for my problem. Then I have to so now that I have my set of features, I can take a data item or an object. So data item is an object, and represent it as a feature vector. So an object in a machine learning data set is always represented as its feature vectors. So an object is defined by its features, right? So it is defined by its feature vector. Then I will populate my feature space with all the objects which I have to create my data set, my machine learning data set, and finally I will use this data set for learning tasks, right? Uh, and Yeah. So now, in order to get these define these features, so I need to do something called feature engineering, right? So feature engineering involves the definition of appropriate features and the the you know the defining each object as a feature vector. So there are three basic cases which can arise. So first of all, if I have a set of well composed features which is available to me, so this is the easiest case. So there is no real feature engineering which I have to do myself. It has already been done for me. So I know a set of features, and I know that they are accurate, they are appropriate features to be used for the problem, and I can just go ahead and use them. I'll come to the second case. I'll talk about the third case first. So which is that the data is non-digital and the features need to be extracted manually. So this means that so there are certain kinds of data which uh, f- from which I need to extract the features manually. They are in non-digital form, so I need to extract each feature manually and see if they are appropriate for my learning task. So this is the most work intensive, I would say, in terms of how much time and effort we need to put into this. And the second case is the most commonly uh, appearing scenario, which is I have a large number of possible features, uh, and I need to reduce this huge set of features to a manageable size. Because you could argue that why not use, why not just take this huge set of features and just feed it to my learning algorithm, and it should be able to learn, right, a large number of features, which means my data is very well defined, and I should be able to get a better performance out of my model. So there are certain problems associated with that. Uh, there are some reasons why we don't want to use a very large set of features. First of all, it is very difficult to interpret. So if I have say say 10 or 20,000 features describing a particular object, then that is very difficult to interpret as humans, right? Secondly, it massively increases computational time. We want our algorithms to run fast. So, say a self-driving car should be able to reconstruct scenes in a matter of milliseconds. So, it does not have time to sit there and compute for 5 minutes and then it goes driving, right? So it needs to every a machine learning model should be able to compute as fast as possible. Then there's the curse of dimensionality, which I'll talk about in a little bit, and we also run the risk of overfitting. So I'll discuss these two concepts. So what is the curse of dimensionality? So in case we have a large number of features, what happens is that so say you have a very large number of features, but you don't have a large number of objects, right? So you don't have a large number of data required to support these features. So as the number of features increase, right, my model, so my machine learning model will try to learn all these features, and will try to learn all these features. And the more number of features I have, the more complex the machine learning model gets, and I will require more data to properly train this model, right? So this high dimensionality of features is not ideal all the time, because I may not have this much data to support the large number of features. And high dimensionality also causes the objects to become very dissimilar from each other. So if I have, say, again 10,000 features describing an object, so when comparing two objects, there will obviously be a lot of dissimilarities between the features, and this can hinder my learning algorithm, because it is unable to find common patterns in the data which it can exploit. This is also a problem of high dimensional data, right? And finally, uh, if we have a large number of features and not enough data, then what usually happens is the learning algorithm overfits the data. So this is called overfitting. And what happens is the learning algorithm will memorize the data set. So whatever data set you give it, so it will just memorize it, and but it is unable to generalize after that. So if I give it an object which is not part of the data set, so which is what I want to do with my machine learning model. So the point of training a machine learning model is that I should later be able to give it an unknown object, and it should be able to predict its features, right? But if a model has just memorized the data set, it is unable to generalize. So if I give it a new object, then the performance of the model is very poor, right? It will not be able to memorize it will not be able to predict the features of this the new object which I give it, right? So yeah, so finally, this one last concept which I want to discuss, which is feature selection versus feature engineering. Sorry, not feature engineering, actually it should be feature extraction. I wrote engineering by mistake. So feature selection involves, so I have a large set of features, and I just select a subset of relevant features which are important to me. So on what criteria should I select those? The first is the information contained. So there are certain data analysis techniques which help us figure out the amount of information, or the importance of a particular feature in the data set. Then there's relevance. So the feature that I select uh, should be relevant to my problem. So say I want to predict the price of a house, then I should not be selecting non-relevant features which won't help me predict the price. So there are so this information content and relevance is very closely linked. And finally, the features which I select should be non-redundant. So say, yeah, again, I want to predict the price of a house, and I already have selected the area of the house. Then then if there is a feature, say, in this large set of features, which is the square of the area, right? So I don't need to select that. I already have selected the area of the house. Then I should not be selecting the square of the area as a feature, right? So that would be redundant. Non-redundancy is also a criteria. Uh, Again, I think there is some noise which is coming. Um, okay, mute this person. Yeah. Anyway, so that was it about feature selection. And what do I mean by feature extraction? So this is extraction, not engineering. So feature extraction refers to deriving new features as mappings from the original features. So this could be simple combinations of adding two features and creating a new feature, and using that instead of the separate features. Or it could be more complex mappings from the original features. But in any case, whatever features I select or whatever features that I extract, the learning algorithm should improve its performance on this new feature space over the old feature space, because if it does not improve, then there was no point of me selecting all these features, right? So yeah, I think that's it from my side of the slideshow. If you have any doubts regarding this presentation or in general about the course, then please you can ask me. Okay, I think people are typing in the chat. So regarding sharing this PPT, I think the NPTEL team will share it with you. So I have been asked to upload this PPT, so I am sure it will be shared with you. And can I ask questions related to this slide between the so you want to ask something from the presentation, right? So yeah, please go ahead. You can ask me to go back in the slides. So So yeah, people who have raised their hands, if you want to unmute yourself and ask a question, then please go ahead. Can you explain the feature engineering part again? What is a vector? Okay, so I will go to the feature engineering slide. Okay, so okay, a vector is something. Okay, let me see if I can explain it. So say again, I'll take the example of predicting the price of a house. So the price is my target, right? I want to predict the price, so that is my target variable. And the so say a particular house is defined by certain features, right? So it is defined by the area, it is defined by number of rooms, it is defined by what else, say number of bathrooms. Okay, so like if I collect what happens in a what usually happens in a machine learning task is I will collect all these features. So area, say it is 500 square feet, it has three bedrooms, it has three washrooms, so it's 500, 3, and then some other features. I will collect all of these in a vector while I am training my machine learning model, and I will call that the feature vector for that particular house. So does that clear your doubt? Okay, can you give a real world example where you don't have enough data to describe the feature of an object and dimensionality of feature vector creates a problem? Okay, so I mean, you can think of it you can think of examples like this, like uh, okay, a real world example. I'm trying to come up with something apart from predicting housing prices, but okay, at the moment I can't really think of anything like that, but okay, I'll try to explain it. So uh, say I have 1000 features representing my representing the house, right? Say I have 1000 features, but I only have a set of like say 100 houses, right? And I want to predict price. So what happens is while the this is so here I have each house is represented by 1000 features, but I only have 100 houses in my data set. So what happens is while I am trying to train my machine learning algorithm, what will happen is uh, due to this large number of um, features, my machine learning model will just memorize the prices of those 100 houses instead of creating a proper generalization, right? So what I want my machine learning model to do here is to find the trend in price, right? Find the trend in price based on all these features. But if I have these large number of features, what happens is my machine learning model will just memorize the prices instead of learning the trend. And when I give it a new house to predict, so say I give a new house and I tell it, so what is the price of this house, it will definitely give me a wrong answer, because it has only memorized the data set instead of learning the trend. If it had learned the trend, then it would have given me a proper prediction. But since it has just memorized all the prices of those 100 houses, so it will not be able to give me a proper answer for the new house, right? So this is I will so I'll try to come up with a better example next time, a proper real world example where this is a problem. I can't think of anything off the top of my head right now. uh, so I'll come back to you. Okay, what exactly is a vector? Okay, is it just holding space? So I am talking about vectors because so when you actually go on to actually code a machine learning algorithm, or you want to actually build a machine learning algorithm, you will do it in something like Python or MATLAB. So what we do is all these features which I talked about. So say this area and number of bedrooms and whatever. So all these all these features are put in a vector in MATLAB or in Python. Okay, so that is why I keep saying vector. It is you can think of it as a list of features. If you don't want to call it a vector, think of it as a list of features. Okay, I hope that yes. Okay, there's one question which I missed here, which is can you please give a brief description about mining and what is data mining and text mining? So I have to admit that personally I don't have a lot of experience with data mining or text mining, but I will still try to give you an explanation. So what we do in data mining is that so let us go back here. Yeah. So what we want to do is we have usually a large collection of very unstructured data, and the goal of a data mining algorithm is to extract the patterns from this data set. So if you look at the examples, maybe it will be clear to you that so say I talked about Amazon, right? So there are millions of people who are using Amazon every second, and they have and Amazon has a huge collection of data about which products people view. So say you are looking at a phone, right? So say you're looking at a phone, and so there are millions of people looking at this phone on Amazon, and then after looking at this phone, say they look at say they look at another product. So what Amazon will do is, using its data mining algorithms, it will try to figure out that what is the most likely thing which people are viewing after viewing a phone. So usually say it will be a phone case or a screen protector, something like that. Okay, and then Amazon will predict, will suggest to you. So when you are looking at that phone, Amazon will suggest to you that these are products which people have viewed after viewing this phone, which is a phone case or a screen protector, something like that. And this obviously, if people are considering buying the phone, then they'll obviously consider buying a case or a screen protector, and this boosts their sales, right? It is also used in recommender systems, as I said. So in apps like Netflix, so the way Netflix recommends movies or TV shows to you is based on their data mining algorithms. So they have a large collection of data, and they know that okay, so say 20,000 people watch this movie, and after watching this movie they watched this other movie, right? So when you are going to watch that movie, Netflix is going to suggest the most likely movie which you would want to watch after watching this particular movie, right? So it is used in recommender system. Social media has a similar uh, like it has a similar approach to this. Then it is used in, we have financial data sets. So businesses try to see their so they try to observe patterns in their sales or patterns in their in their I mean the growth of their company, something like that. So these are. So I think hope this clears your doubt. Just will you please share this PPT? So yeah, I have been asked to upload this PPT to by the NPTEL team. So I'm sure they will share it with you. Yeah. Could you explain the difference between supervised and unsupervised learning? Okay. So okay, I will do this. So what happens in supervised learning is that, so again I'm going back to predicting housing prices. So so you see that I have some features, area and number of bedrooms and whatever, and uh, so I have this list of features, and I also have something that I want to predict. I want to predict the price, right? So I have a target variable which I want to predict. I want to predict the price. So this is so these kinds of problems, and even in classification. So there are so say I want to classify the kind of vehicle. So say I have images of cars and trucks and buses, and I want to put them in different categories. So I have some targets, right? I have three targets. I have a car, bus, and truck, right? Which I want to put them in. So these kinds of problems are called supervised problems because they have a target variable. But in unsupervised problems, we usually don't have. Not usually. We do not have a target variable. So it would be something like, I'll give you an example. So say I have so say I am a t-shirt manufacturer, okay, and I have the data of say 10,000 people, of their heights and weights, and I can create a distribution out of that. So usually it will be an increasing distribution. As height increases, weight increases. Usually it is like that. So say I have this distribution, and I want to create four sizes of t-shirts, right? So I want to create small, medium, large, and extra large, XL. So I want to create these four sizes, and so how do I know that which category of people would want to wear an S sized t-shirt? Because I have to like have some dimensions of my t-shirt, right? So I can get the dimensions of my t-shirt using this height and weight data, but I should know the limits that this category of height and weight people will wear an S size t-shirt. So this category will wear M, this will wear L, and this will wear XL. But I don't know. There is no real target here. Like I don't know this particular group. So what I'll do is I will try to form groups basically. I will employ a machine learning algorithm which can group these 10,000 people based on certain similarities. So this is called a clustering problem. So you will come across this for sure. This is called a clustering problem. I will create some certain groups based on similarities within these data points. But I don't have, so I just start off with heights and weights. I don't have any target to predict here. So this is what the difference is between supervised and unsupervised. I think I did not do a good job explaining it, but I'll try to explain it to you with the proper image next time that I have a session. Okay. Apart from Tom Mitchell's learning book recommended by the questionnaire, could you please recommend alternate books and other resources to prepare for certificate and supplement the lecture? So, I personally don't have any recommendations for books apart from Tom Mitchell's book, because I have also been only studying that book. If you want to like if you want more knowledge in this case, you can think of there are more courses which are available online, so you can go through those. There's a course by Andrew Ng, which is very popular, machine learning by Andrew Ng, which is very popular. You can find it on YouTube, you can find it on Coursera, it is free. And yeah, if you want to, so he takes a very a very hands-on approach to it. He will teach you how to code and everything. So if you want to learn how to code, then do that course, then take up some projects. So yeah, that's it. um, could you explain two point crossover? Okay, I have to admit that I don't know this concept myself. I would get back to you next time with the answer to this question. I noted down myself. So I'll definitely get back to you with the answer. Okay, are there any questions which I have missed? Does not look like it. Um, okay, the alternate course, I will type it out in the chat. It's machine learning by Andrew Ng. It's a free course. You can find it on YouTube as well. It's a pretty long course actually. So I mean, you can consider doing that, but it is a very long course. But it will teach you how to code, and after that, I would recommend you take up some small projects. You can go to this website called Kaggle Kaggle.org, I think it is. No, Kaggle.com. Yeah. So Kaggle.com has a lot of projects which you can take up yourself. So there are small projects, there are competitions which go on in Kaggle, which are very interesting. So if you want to participate in those, yeah, that's good for you. So are there any other questions? Okay, I should say that I think the deadline for submitting your week 2 assignment is 9th. So I think my fellow TA will have another session before that. So if you come across any more doubts, then you can definitely ask him. Uh, and so I think the deadline for week 3 is 15th. So I will have another session before that. Yes. Yeah, so I will have a session on 13th. So if you have any doubts on week 3, then you can ask me, or yeah, there will be two other sessions by my fellow TAs as well, so you can ask them as well. So where can I find recordings of the two previous sessions? I am unsure of that. So I have not been informed by the NPTEL team about where those have been uploaded. Uh, the sessions were definitely recorded. We are required to record these sessions. But I think uh, if I am not sure where they have been uploaded. I'm sorry. Yeah. Steps in genetic engineering. So by genetic engineering, do you mean you want to know the steps of a genetic algorithm? So that is not part of. I mean, that is not really machine learning. But I just want to clarify because I don't know what you mean by genetic engineering. Okay, week 3. I'm not discussing week 3 content right now. So I would recommend you ask my fellow TA. Yeah, they will have. I think this is a session on Wednesday, and there is another session on Saturday. So there is sessions on Mondays, Wednesdays, and Saturdays for this course. I'll discuss week 3 content the next time that I get. Can you please get them uploaded at least? Yeah, I will. I'll definitely talk to the NPTEL team to get these videos as well as the PPTs to you guys. So I'm sure they will do it. Um, but I can't promise you anything because yeah, even I am not part of the NPTEL team. I'm just a TA who is helping out. Is it on Tuesday? I think it's on Wednesday. So I think yeah, it's on Mondays, Wednesdays, and Saturdays. I think yeah. There is no session on Tuesday as far as I know for this course. Okay, someone has raised their hand. So if you want to unmute yourself and ask a question, then please go ahead. Or if you want to type in the chat, that is also fine with me. There are still people who are joining. So if you guys have any questions, then I've already discussed whatever I want to discuss. So submission for week 1 is 9th. Submission, I will just check and tell you. So week 1 submission, yeah, it's on 8th actually. So it's on Wednesday. Yeah. Week 2 is after that. Week 2 is so week 2 is also 8th. So okay, I think both of these have the same uh, deadline. Yeah, both of them are on 8th. For week 3, it is on 15th, I think. Yep, it's on 15th. So yeah, there's genetic algorithms are part of week 3. I'll definitely discuss that the next time I have a session. So yeah, these people. I don't have the privilege to extend the deadline, man. I'm sorry. I'm sorry. I don't have the privilege to do that. I don't think I can request the NPTEL team to like extend the deadline as well. I don't think they will accept that. So yeah, I mean, I am not a part of an NPTEL team which conducts these courses. I'm a student. I am also a student, and I've been assigned as a TA in this course. So I just help with these sessions. Okay. Are there any other questions? There's still one person who has his hand raised. I don't know if you want to ask a question. And is machine learning a scopeful one to learn? Okay, so I'm thinking you are asking about the scope of this course. So yeah, I mean, if you look around, every business and every company right now is putting AI and machine learning in their products and services. So yeah, I think it has a huge scope. It is the future. So teaching, you think about it, teaching machines how to think like humans, that is a pretty big step in humanity, I should think. How is the scenario going to change for ML engineers after chat GPT? Okay, so we are getting to uh, whether I'll answer the next question first, which is whether an electrical engineer can manage to learn machine learning. So I am a mechanical engineer myself, and I still manage to learn machine learning. So it is not difficult if you are thinking about it. It is, I mean, building machine learning systems is very easy nowadays. So there should be absolutely no problem. I would recommend. If you have a slight background in coding, it definitely helps. But I mean, Python is a very easy coding language, like very easy language to learn. So I don't think that like even if you don't have a background in coding, I don't think it should be an issue. I mean, you can learn it pretty fast. Okay, now coming to this, how is the scenario going to change for ML engineers after Chat GPT? I mean, if you're talking about Chat GPT, learning, I mean, Chat GPT can write code for you as well. But as far as I know, I don't think it can write full machine learning algorithms by itself. So I think ML engine is a pretty safe for now. Uh, I mean, it is a very difficult question to answer. How is it going to change? I mean, only time will tell how Chat GPT improves. I mean, if it definitely has scope to improve, so I don't think ML engineers are going to go out of jobs, but I definitely think that the bar for becoming an ML engineer, so the amount of knowledge which you need to have, that will definitely increase. So yeah, future scope in machine learning. So future scope in machine learning, what can I say? So the the closest which we have right now is yeah, autonomous cars, self-driving cars. They are already on the roads. So I believe it's a matter of 5 to 10 years before when self-driving becomes it becomes a proper reality. And what else? So machine learning has it has huge applications in robotics. So teaching robots how to function. So that is based purely on machine learning. So that is one of the big areas of research right now. So please explain machine learning problems. So this week, for week 1 and 2, there were not a lot of mathematical concepts which are discussed. So from week 3, I will be discussing problems instead of giving a presentation. So I will be discussing some sample problems. But currently, for week 1 and 2, I don't have any sample problems to solve because it is mostly theoretical. The most of the answers to the assignments are in the videos, so there is nothing that you need to calculate or anything. So I think you should be pretty comfortable. Do we have any guided project in this course? I don't think so. I think we only actually, yeah. So week 7 and week 8 content will be project based. So I think you will have proper hands-on experience as well. But in terms of some of the assignment questions will be based on you coding something up and you trying to answer that question. Then, yeah. What is Hamiltonian graph? So I don't think. So I would request to stick to week 1 and 2 content for now. I will discuss week 3 content once, but for now, there are people who are raising their hands but not asking the questions. So, guys, if you want to ask, then
Yeah.
you're free to ask.
Uh,
Yeah.
this I see there is a session on Tuesday, sir. Can you just
Is there a session on Tuesday? Just 1 second.
7 to 9? Yes.
Is there a session on Tuesday? Oh, that's right. I am so sorry. It's on Tuesday. I am
Yeah, that's
sorry.
okay. Yeah, I
Not
got
Wednesday.
confused totally. Yeah,
I'm so sorry about that. So sorry about that. So we will have sessions on Mondays, Tuesdays, and Saturdays. Sorry, not on Wednesdays. Sorry, sorry. I got confused with a different course. So yeah,
No problem. There's another question is that
yeah,
Hamiltonian
sure.
graph is not a week three thing, it is a week one,
Is
two
it
thing.
week
It
two?
was asked in the week one
Just one
also.
second.
This is a
Just one
DAG
second.
graphs.
I think I have not come across it, so I am unable to answer that question. But okay, I will definitely. I'll note this down for now, and I will come up with the answer. I'll give you a proper answer next time. There are certain questions which I have to answer
Uh,
next time anyway.
there is a directed graph, uh, something like that, DAG graph. That is what I
Okay.
DAG.
Mm, yeah, there is actually. So anyway, I'll not play the video now. I'll answer the Hamiltonian graph question as well next time. So there's 2 point crossover which I need to explain as well.
That's in the
There's
third week.
yeah,
That's in
yeah,
week three. Yeah,
yeah,
no
yeah,
problem.
that's in week 3. But still there are some other concepts. So okay. I mean, yeah. By the way, there is no. I mean, there is no pressure to call me sir. You can call me by my name, Sagnik. I'm just a student, so I am fine with you calling me by name. There is no pressure.
So the
Okay,
coding is
guys.
absolutely necessary that we should know some coding for this course.
I
I
mean,
don't because
it
I am
is
also a
it
mechanical
is
engineer. So
it is not necessary to whatever that we learn is mostly mathematical concepts, but I mean the you will I think personally that you get the fun and the essence of machine learning when you code a machine learning model and it works, and you can see it predicting and you give it an example and you see it predicting the correct outcomes, and that is where the fun of machine learning is for me. So I would highly recommend that you try a little bit of coding. It is really not that difficult. It is actually very easy to do machine learning nowadays. So I would really recommend it. But no, I mean it is not necessary. You will definitely learn the mathematical concepts through this course. So that is yeah. I mean that
my
is
point is
enough.
just for this course,
Yeah.
do I do I need to learn
So far, I think for week 7 and 8, there will be a small guided project. So for that, I think you would need a little bit of coding knowledge. So uh,
thank you.
yeah, sure, no problem. So any other questions, please?
This overfitting,
Uh,
underfitting, and
yeah.
exact best fit. Yeah, I just wanted to.
Overfitting and underfitting is like it's like two sides to us to the same coin. So
Yeah.
there is overfitting happens when you have a very small a very small number of objects, but a very large feature set which the model has to learn. So it will just memorize the data set, and that is called overfitting. Underfitting happens when you do not. So it happens in the other case when you have a lot of data, but you don't have a lot of features. So the resulting model is very simple. So a very simple model, if you feed a large amount of data to a very simple model, then it will usually tend to underfit. It will not even learn the features of the data set correctly. So when you give it a new example, then it will again predict the wrong outcome. In both cases, the result is that if you give it a new object, an unknown object, then the prediction which the model gives is incorrect. So there is a balance that we need to find between the amount of data and the number of features. So this is done through feature engineering. There are some other ways to increase or decrease overfitting as well, which we'll discuss in the later weeks. So yeah. So there
This
are
target, yeah,
yes, yes,
this
please
target function actually,
yeah,
when it's a checkers problem, it was like a linear model which was actually given.
yeah.
So that was not really able to compete with the world-class players. So then the models became more complex, and then it has to play with itself, the machine, and then it
Okay.
becomes.
So yeah, that is what you are talking about is so in order to play a game, that is a case of reinforcement learning, I should say, not really a target. So there is the only target in reinforcement learning is to maximize the reward. So there is a certain algorithm which computes a reward for the model, and if the model takes a correct, if the model makes a good, so if you're talking about checkers or chess even, so if the model makes a good move, then yeah, the reward increases. So that is how the model knows that from next time I should be making this move. That is how it is in games. And in terms of playing with itself, so playing with itself is not a part of reinforcement learning, first of all. So that is something which I don't know if you have heard of
I mean,
this.
how does it improvise its own capabilities actually? The algorithm
Okay, so
to meet the best standards.
yeah, so I didn't really get your question.
No, no. What I mean to say is that if it was a if the target function is a basic linear function, where
Yeah,
we assign some weights and
yeah,
try, then it is not a very competitive program.
yeah,
But
that's
when we
right.
when we modify it, and then the permutations and combinations, it's like a probability
Hmm.
increases when it self improvises, when the machine self improvises by playing with itself.
Hmm. So so you're talking about these weights, right? So
Yes.
the machine, the model will improve these weights and try to better itself. But what I want to say is that this playing with itself is not a part of machine learning. So that is not where the machine, I mean, this concept of making the machine play with itself is something which is different from machine learning. So once it plays with itself, then it can apply all the machine learning concepts, and I mean, it has its idea of rewards, and if I make this move, then this is a good move and I will get a reward for this. So when it plays with itself, then it improves, yeah. But the idea that I should make this model play with itself is not intrinsically a part of, I mean, the machine learning process, the reinforcement learning process. This is
Okay,
what I want to
but
say.
this has to be the purpose, right? I mean, unless until this is a credit of bettering this thing algorithm is
Yeah,
there.
so this is what I mean was found through research, that if you make it play with itself, then it improves, right? But earlier, I mean, in general, what happens in reinforcement learning or in machine learning problems is that you either have so in machine learning you have uh, your uh, your your data set which you have collected from somewhere, okay, from multiple sources, and in reinforcement learning you just have this agent which is trying to navigate through, I mean, make some moves and increase its rewards, right? But I mean, yeah, I guess I am also a little bit confused with your question, so just I am not able to answer it very clearly.
No, no problem. I mean, like this example of concept definition, like there is a hypothesis language and there is a
Yeah.
generalization and there is a wild card. So uh, I think I'm clear, right? Suppose there's a fish and then there are few wild cards. So that gives us the
Yeah.
different varieties of fish in that.
Yeah, that's right. Yeah.
Okay. So this is a subset of object space. Is this or a I mean, how do we actually exactly understand an object, a category definition?
Ah, okay, okay. You are asking about that. Okay. So, see, an object is one particular example, okay, and I will define this object using so this object exists in a population, and I will derive my object space from it, and I will define some features of this object which form the feature space, and so each object is defined by a certain set of features. So that is how it goes.
No, I mean to say, suppose there is a zoo data set,
Yeah.
and there is something like some animal is there.
Yeah.
Okay, different varieties of fishes are there. So there is a
Okay.
fish, and then you give a generalization in which you leave two or three wild cards, and then that changing the wild cards, you get different varieties of fish. Is that the way? I mean, hypothesis language is the same as object language, apart from the introduction of wildcard or ordinal feature variables.
Ah, okay, okay. Yeah, yeah, yeah. That's right. Yeah. Um. Okay. Mm,
And what
yeah,
is
I
the
mean,
concept hierarchy? Hierarchy?
sorry. Okay.
The
Okay. So we'll go back to this. Our, sorry. So, so concept. I mean, yeah. Here. Yeah. So, yeah. This is a little bit off, but okay. So, concept hierarchy. It means that, I mean, this sort of structure is usually um, this is like so say I have different categories of fish, as you say. So these are like, so if you think about, so you can think of concept hierarchy like, so I have these different species of fish, and then some species will be generalized to a particular family, and those families will be generalized into a genus, or how the so uh, how the uh, in I mean, since you're talking about animals, how the biological hierarchy goes. So there's species, and then there's genus, and then there's family, and then there's on top of that there's more things. That is how we build a concept hierarchy. So
No,
this
I just want you to explain this direction arrows as to what does it mean? It means category 5 and 6. What is the direction and what is it directing to?
Oh, okay.
Category 2?
So the arrows basically mean that this category 5 and 6, they are as you said, there's some wild cards, right? So when those wildcards come into effect, there are some certain specializations which appear. So from category 2, it specializes into category 5 and 6, but category 5 and 6, they generalize into category 2. So that is why these arrows are pointing up. So category 5 and 6, as category 2 is the generalization of 5 and 6. 7 and category 3 is the generalization of category 7 and 8, like that. It's all of them are called categories, which is, I think, there is some confusion, but you can think of them these two belong to the same family, and these three, then they belong to some superset, which is which contains. So okay, let's start from category 1. Category 1 has some particular number of features, right? So from there, I can add some more features and specialize them into category 2, 3, and 4, right? And then I can add some more features and specialize them into category 5, 6, then 7, 8, like that. So the I can either have, so if you see in this, I think it will be clearer. So I can either have arrows going down, which means that I am specializing more and more. In this case, if I just flip the direction of the arrows, instead of generalization, I will write specialization. So I specialize category 1 into 2, 3, and 4. Then this 2 again breaks apart into 5 and 6. 3 breaks apart into 7 and 8. It specializes into 7 and 8, like that. So that is how the hierarchy is built. I mean, you can either put arrows going up from each specialization into the general category, or you can have arrows going down as you specialize one category into multiple different categories.
But where is the root specified? I mean, I just want to know that the whole thing starts with the branches or it starts with the root?
Oh, okay. So, I mean, usually, if we are thinking about machine learning problems, then we would usually start with the root and then specialize and specialize to get into these subcategories. Uh, but yeah, I mean, that is how it is usually, as far as I know, in machine learning. So, yeah, I have not come across any example where we start with the branches and go up to the root.
Now there's
But
something, but yeah, please.
I mean, this is I think it was easier to explain for the professor, so he put the arrows in the opposite direction.
That's right. I
I'm sorry.
was
Yes.
thinking it was coming from the other side. Uh,
Sorry. Yeah, here.
now, for example, there is a fruit, and then there is example of apple, peach, grape. Apple
Yeah,
again, delicious, and the types in that. So subcategories.
yeah,
So
exactly, exactly.
how this feature? So these levels, how do we? That's what. From where do we come from? Which come from the fruit only, no?
Yeah. We start from the fruit. Then there's apples and peaches, and then there's yeah the further subcategories of those. Yeah, I think yeah. So here the professor has given an example of
Yeah, it's a good
this
example.
buffalo. So yeah, I mean we start off with at the top, right? So this is the most general case. So animalia, and then you go down and down. Finally, you reach this. I mean, this is the species, I think. And this is called genus. This is called family. And on top of that, something. Yeah. Okay. So there are. Where I get notes for ML. Notes. I think the lecture notes are shared with you anyway, so you can use those definitely. I will try to see what the situation is with these video recordings and the presentations which we are giving as TAs. So I will look into that a little bit, so that I'll see if those are made available to you guys. I'm sure they will be made available. I mean, I don't think there is anything outside the video which has been put in the assignment. So, if you watch the videos carefully, I think you will get the answers to all the questions.
There are two parts of that. One is from the videos. Other is from the material he has actually given. So he
Okay.
says clearly in the transcript that few of the questions, and he has given the question numbers also. So from this questions, this videos can be answered, and then the rest also he mentioned which particular thing. That's very clear if you can
Yeah, I
transcripts
mean, there's
class.
yeah, we
Yes,
have
it's not covered
some.
totally in the videos, and it's not totally in the videos.
Yeah, just one
Those,
second.
yeah,
So yeah, I mean, there's we have further reading material as well. So you guys click here.
yeah.
Then yeah, sorry. Yeah, sorry about that. I have a little bit of a cough. So so yeah, you
No,
can
not
have.
the reading material is that Alan Turing lectures.
Hmm.
There are five. There is that example of that. There's a, 1960 problem that those are the reading materials.
Yeah. That's right. So as far as I know, I don't think. Those-
No, few questions. Most of half can be
yeah.
answered, but
Yeah, half of them can be answered. I, these questions are just. Hmm. Okay, you're talking about assignment two, is it? So what is? No, I don't think there is any question which you should not be able to answer from the. Hmm, you know, I don't see a question which you should not be able to answer from either watching the video or going through lecture notes. I mean, yeah. If you're just reading the lecture notes, that is not very effective. I think. I mean, the video is much more informative. The professor talks a lot about each concept. So yeah, it's six. You're talking about what is the term best suited for the situation depicted in the weather green line estimates. So I think you have to think about what this green line is doing. Like, is it linear separability? Is it overfitting? Is it linear non-separability? Is it underfitting? So, I mean, based on your observation, you should be able to answer it. Yeah. Okay. I will refrain from discussing uh, assignment problems directly. This. So. Yeah, sure. Please go through the materials there.
Do we need to learn the algorithms like greedy best fit algorithm and those other kinds of algorithms?
No, I mean, whatever algorithms that you will need to learn, everything is part of the course. So, apart from that, I don't think you will need to learn any separate algorithms on your own. So, yeah. All the algorithms will be taught as part of the course. So, there are. Yeah. Even in yeah, so even in week 3, right? So we do have our, yeah, decision trees and Bayesian network salience, GS. So
So there's 11 models of 11 models of this unsupervised concept learning and all this discussed.
hmm.
Uh, you'll discuss them also. I mean, like noise.
Yeah.
Uh,
So I will discuss those briefly in the next presentation before I discuss sample problems. So yeah, noise and outliers and near misses, all those. So I'll
time
just
and space
quickly give
learning.
a recap of those. I was unable to do that this time, so I will quickly recap those next time.
So the
Uh,
unsupervised learning is highest concept, is it? Cluster
Unsupervised,
analysis.
I mean, it is not like highest uh, concept. I mean, unsupervised learning is it's a different class of problems than supervised learning. So it's a different kind of task that we are doing, right? So clustering or clustering is a different task from either classification or regression, right? So it's a different class of problems. It's not that it is more complex or more difficult to do than regression or classification. It's just a different kind of problem.
So it involves data harvesting from potentially heterogeneous sources.
Clustering may not uh, in I mean what do you mean by heterogeneous sources? Like, uh,
Not a like different types. Like it's not say animals. Maybe it could be a cat, it could be a dog, it could be some other thing.
yeah. I mean, yeah, definitely. I mean, yeah, it is not like it has to be like all the data has to be like related to a cat in some way. It is nothing like that. Depends on the problem.
If it,
So
if it is related to a cat only, it is supervised, right?
no. So I will explain the difference once more. So supervised problems. What happens in supervised problems is that we always have some sort of a target variable, right? We always have some sort of a target variable which we want to predict, right? So say the price, or say the kind of animal, it's cat or dog or cow or whatever. So there is always some sort of target, but in unsupervised learning there is never a target variable. So if you think about clustering, right? So if I want to put my data into different clusters, there is no real, the only target you can say is the number of clusters which I want to have. So if I want to have 10 clusters or 20 clusters, then that is the only parameter which I can give my model. But apart from that, it only has its data. So the example which I took, it was heights and weights, right? So I have a collection of heights and weights of different people, and I just want my model to cluster them into say 5 groups or 4 groups or whatever. So there is no real like target variable which we want to predict or which we want to yeah, look at like that. So that is the difference.
So it can learn also the concept heuristics observations into subsets, so
Yeah, I
that
mean,
observations within the same cluster are similar. That's what it means.
yeah, that's right.
So learning multiple concepts from unsorted examples is
Is
unsupervised learning.
unsupervised learning. Yeah, yeah. I
Okay.
mean, yeah, you can think of it like that. Yeah.
Yeah. And there is a distinction between feature selection and feature extraction, right? So now,
Yeah.
now this feature extraction is a process of deriving new features. Either can you just
Yeah.
explain the feature extraction, please? Because there's a
Okay.
question in the assignment, but this was also confusing. The options were confusing. So I just need a clarity on that.
Okay. So I think feature selection is pretty self-explanatory. It is just I
Yeah,
have a large set of
informativeness,
features. I
relevance, and
yeah.
non-redundancy.
Yeah. That's right. So in feature extraction, what we want to do is um, say I have say 2 features, and I just instead of uh, so see the way that we either select or extract features, I mean the way that we do it is there are certain data analysis techniques which we use to either select or extract these features, right? So if I create a new feature out of say a combination of 2 or 3 features, and then I test its I test the information it has, whether it's redundant, and yeah, so the conditions which I gave here, and whether it's relevant. So first of all, make this
No, no,
extraction.
not this. Feature extraction.
Yeah. So I mean, so the new feature which I have mapped from my original
Multiple
features. So say it is
combinations
a
of, yeah.
Yeah, so it is a combination. So it can, so say I add three features and I make a new feature, and I find that it has more information, it has more relevance, it is non-redundant. So and like on including that, my learning algorithm is improving in performance. So I would select that new feature instead of the older three features, right? So so the mapping does not have to be like just adding two features or something like that. I can take one feature and take its Fourier transform or something like that, and create a new feature out of that. So that might be more relevant, and that might contain more information than the non Fourier transform data. So that is what feature extraction is. So feature extraction basically means I am creating new features out of the existing ones. But feature selection basically means I am just selecting a subset of the features from my original set.
But it says in both the cases, the learning task is supposed to be more tractable in
Sorry.
resulting feature
Yeah.
space
Yeah.
than in the
So what?
original independently. So that is what is
Yes.
the point, right?
Yeah. So what that means is that I mean, what that means is basically on using this new feature space, on using this new collection of features, my learning algorithm should improve its performance, right? So if it does not improve, then there is no point of me trying to make new features or select these features. So that is what I wanted to point out in this last sentence. Okay. Uh, are there any more questions? I don't see any more questions. So yeah, I'll wait for a couple minutes. If there are no questions, then we can end the session for today.
Uh, what is
Yeah.
the best way to reduce the learning tasks to one or more function approximation problems? I mean, what are the specific functions should the system attempt to learn?
Oh, okay. So yeah, in machine learning, we don't aim to train, like, to learn a specific function. The I mean, there is no like there is no predetermined function which I would want my system to learn. I would let the system figure out its own function. Like, it will learn a function, obviously, of the inputs, but I will not like force it to fit any particular function or anything like that.
Can this process itself be automated?
Yeah, that is what training the algorithm means. So I give my inputs is my data. So I give my inputs to my model, and the model will train on that data. So that is so by training, it will basically learn a function of it will basically map the inputs to the outputs. So it will learn a function of its inputs, which is given by the data.
I mean,
So I
how
mean,
can the learner, yeah, please.
yeah, you can ask.
How can the learner automatically alter its representation to improve the ability to represent and learn the target function?
Okay, so yeah, I mean, these are these algorithms are what make up machine learning. So like this is what you'll be learning in this course, that how exactly do I make the so how exactly do I change the function representations from how do I keep changing the function representations to create better mappings basically. uh, if I'm like
Yeah,
if,
like what algorithms exist for learning general target functions from specific training examples?
yeah, exactly. So these are the algorithms which make up
In in
the machine
in
learning.
what settings will particular algorithms converge to desired function given sufficient training data? And how much should be the training data?
There is so here is where uh, I think you are making a mistake, is that there is no desired target function. So I mean the machine learns what it will, if I can say that. So the machine will learn a mapping from the inputs to the outputs, but in most cases it is usually if you just go in and try to understand what function it has learned exactly, then I don't think you will be able to understand that. So that is one of the big, this is one of the very big points in machine learning, is that sometimes it just looks like a black box which is taking inputs and throwing outputs, but you don't know what exactly the function is inside. So it is I mean it is still a topic of research actually, that how exactly can we understand what function the model learns. So
Like,
this is not something, I mean, uh, there is no desired function which I want to fit to my model, right? So that is the difference from traditional curve fit. So if I want my model to fit a particular function, then that is basically curve fitting, right? So I mean then if I mean curve fitting algorithms already exist, so then there would be no point of machine learning itself, right? So there is no predetermined function which I want to fit to my model.
can prior knowledge be helpful even when it is only approximately correct?
Yeah, I mean, if so, yeah, there are ways in which we can encode. If we know some, sorry, so if we know some data, if we have prior knowledge about the system, then yeah, we can definitely encode it in the machine learning model. I mean, however little knowledge we have, we can encode it, and it helps the model to learn better, to learn faster.
And how can the learner automatically alter its representation to improve its ability to represent and learn the target function?
Sorry, can you
Yeah,
repeat?
how can the learner
Huh.
automatically alter its representation to improve its ability to represent and learn the target function? Is it there is a target function? I think there has to be a target uh, function, right?
So there is a target, in terms of target, there is a target variable always. So
Okay.
when training, there is okay, so say I will go back to predicting housing prices. The price is my target, right? So what happens is, during training I will I have my data set, right? What the data set contains is some features. So say this area and number of bedrooms and number of bathrooms, and finally the price of that particular house. So what? So during training, what the model will do is it will try to correlate these values of area and number of bedrooms and everything to the price. So then finally what happens is this price is a function of, so what the machine learning model finally, after training, what it brings out is the price as a function of area, number of bedrooms and number of bathrooms and all this. So now when I come when I come with a new house, so when I give it new values of area and number of bedrooms and everything, it can it has learned a functional representation, and I don't know what that is, like what that function exactly is, but once I give it the inputs, then hopefully it will be able to give me a correct result. So yeah, I mean there are obviously ways in which you can check the performance of the model. Say so from my training set, I will keep apart so some of the examples, so which I can feed later to see if it is giving the correct result or not, right? So I can do things like that. So I mean we can obviously check the performance of the model, but ideally what happens is after training and our checks are complete, so we have a model which is basically a functional representation of the price as a function of area and number of bedrooms and all this.
Thank you.
So
I think we are running low on
uh,
time.
yeah, we are yeah, it is actually time. So yeah, I think I hope I was able to clear most of your doubts, if not all of them. There are some doubts which I will clear in the next session. You can also ask them to my fellow TAs. So there's one session tomorrow as well. So they are also part of this course. They will help you. You can also ask them. But otherwise, I will come back next Monday and we'll discuss. Yeah, then I will quickly go through the the small amount of stuff which is remaining from week two, and we'll move on to some sample problems, right? So yeah, thank you guys for attending this session. It was yeah, I hope you'd also cleared. Yeah, see you next week. Yeah, thank you.